Okay, we'll start the finite series. The finite series, you will be exposed with forward, backward, and centered difference. Okay. Okay, basically, f prime x is the differentiation, whereby the differentiation is equivalent to dy dx. We know that dy dx is the difference between 2 points, right? Like you want to identify your slope. Okay, last time when you are drawing your graph, linear graph, you want to find your slope, delta y over delta x. So that is dy over dt equivalent to f prime x. Okay, differentiation. Okay, apart from using the calculator, we can use this kind of equation. Okay, we know that f prime is equivalent to dy dx. So for forward finite difference, okay, for example, we have a curve. Here is the x. Okay, this is fx. Step size. H is step size. Okay, H is step size. Step size is the range, the scale. Okay, so step size over here is x I plus 1 for the new point. So in between here is h. For example, let's say x is 5, xi plus 1 is 6. Okay, so what is the step size? 1. Okay. So fx plus h means this point. F at for this point, forward. Okay, forward plus, it means moving forward from the original point, the x over here, moving forward. Okay, minus fx. This is for fxi plus 1. So this is fx. So fx plus h plus h. Okay, don't get confused. This one, x plus h over here is similar to xi plus 1. Okay, understand the term? Okay, so now fx plus h minus fx over the step size. Step size over here is 1 for this example, for this value. Okay, so this is the true derivative at fx. This is the approximate value. So, true derivative. So xi plus 1, can see? Is it too small? Try to enlarge. Okay, so this is the true derivative. True derivative for fx. Now, moving forward, adding the step size, fx I plus 1. So this is forward approximation, moving forward. If it moves backward to xi minus 1. Okay, for example, just now we use 5. Step size is, sorry, cannot see. It's black color. step size h equals to 1. So 6 here should be 4. Right. So moving backward from the true derivative to backward. Same h as well. Okay, so this one is xi minus 1. Okay, how is the equation for backward? Fx minus the backward one, the previous, over the h. For the forward one just now, this one is, let's say, f6 minus f5 over 1. Is it the same if you have f5 plus f6 over 1? Same? No. Why no? The value will be different. Okay, it will be the difference. The keyword over here is difference. So you must minus. Okay. Keyword is difference. So this one is not applicable. Okay. Now backward, fx minus the point before, the point previous, divided by the step size. For centered, the forward minus backward value. Okay, from this figure, this is the fx plus h. This is fx minus h. So this is the x just now, the fx. Why 2h over here, not h? Yes, correct. 1 forward, 1 backward. So that's why 2h. Okay. You need to understand the term first. Forward, backward, and centered. Okay. Any questions so far? Yeah, clear? Now for the forward finite difference, this is the full equation where this is the fx plus h minus the fx, the previous one, plus the truncation error. This is for order h. This one if you have order h2. Okay, this one we will do in details in the following chapters. Okay. Now I want to introduce you the terms forward, backward, and centered first. Okay. For forward and backward difference, halving the step size will halve the error. Whereby for centered difference, will quarter the error. Okay, we'll see the example. Using this function, sorry, make it larger. Okay, using this function, can see now. Using this function, estimate the first derivative. First derivative means f1 prime x, because later on you will see f2 prime, second derivative, f3 prime. Okay. So first derivatives mean f1 prime of fx function. Okay, this function. At x equals to 0.5, step size of 0.5, it asks you to repeat the computation using different step size. smaller step size. Okay, we have H1 over here and 2 different step size. Okay, now to find fx at 0.5. Okay, for example, we have x over here. H equals to 1. So here will be, what is the point? The next point? Huh? 1. 1.5. Sorry. H is 0.5. Sorry. Correct. Huh? 1, right? Okay, so this one is 1.0. The backward one, 0. Okay. Okay, now find what is forward. Okay, we start with forward for this function. Forward f1 prime, first derivative. Forward, the equation is fx plus h minus fx over h. Okay, so we need to find what is fx plus h over here. X plus h over here is what? X is 0.5 plus 0.5, correct? .5. So you need to find out what is f1 and what is f0.5. Now find out what is f1. So x over here replace with 1. Try to find out what you get. You know how to set the equation in the calculator? All right. So later on, you just replace the x value. What do you get? 0.2. Yes, correct. The rest, do you get 0.2? Okay, now find out f 0.5. If up to 4 decimal point, what you get? 925, right? 0.925. To make it more accurate, usually I will advise you to use 4 decimal point. That means 5 significant figures. Okay, now plug in into the equation for forward. 0.2 minus 0.925 over 0.5. minus 1.45, right? Okay, now this one is for step size 0.5. Now find out f prime x when h equals to 0.25. With similar method, replace the h with 0.25. So if h 0.25, you will need to find f 0.75, right? Minus f 0.5, right? Okay, what you get for f 0.75? 0.6363, right? Yes. So find for f prime x for h 0.25. What you get? Minus 1.1548, right? Negative 1.1548. Okay, how to calculate the true error over here? True error, true value minus approximate value. What is the true value over here? Correct. Why 0.925 is the true value? Right. Because x equals to 0.5. Okay, why f 0.5 is the given value over here. So this is the true value. True value, which is 0.925. Now try to find out the true error when h equals to 0.5 and h 0.25. True error when h 0.5 and h 0.25. That means using this value for h 0.5, and this value for H 0.25. So true value is this. True error for H 0.5. True error 0.925 minus this negative. Sorry. Wait. Okay. Sorry, I made a mistake. True value is when x equals 0.5, but f prime. Sorry, f prime for 0.5. F prime for 0.5. So you need to find out the f prime for 0.5. Sorry, so this is not the value. The 0.925 is f 0.5, not the f prime. So now you need to find out what is the f prime for 0.5. You need to do the differentiation of the fx. Okay, so just to help you to fasten the process, so actually is already in the next slide. This one, the true value. Here, f prime 0.5. So you will do the differentiation from the main equation. This is the main fx. So true value, do the differentiation, you will get 0.925. Similar as what you calculated, correct? In the calculator. Okay, so this is the true value. Then f prime 0.5 over here is the one that you get from the forward difference using this equation. Okay, I repeat again. True value is f prime from the differentiation process. Differentiation of this equation. Differentiation. Still remember how to do the differentiation? You need to check back your calculus. Okay, so this is the true value calculated from differentiation. This is the value. Now the f prime 0.5, the forward difference, the one that we calculate from the equation, using this equation. This is the approximate value. So true error, true value minus approximate value over true value, 100%. Modulus, the error is in modulus. regardless of the sign. Sorry? True value equals to? Positive. You mean positive? You get for true value, negative 0.925 or 9125? 9125, yes, correct. This is not true. That's not true. The numbers look quite similar. Which is one. So your x plus x is the initial value. And is the value. So x plus You can try to do for backward as well. Backward and centered, whether you can get the same figure. For backward, you will need to find out for F0 and F0.1. Let me know if you need my help. Everyone sign already? Is that it? Okay, organic. Organic lesson. Aiman? Izadin, I know. Gideon? You take organic with who? With me? With Diba? Joel? You take organic with who? Miss Adiba. Lee Zochen. Okay. Abdi Gani? Alim? Sajat? Sarah? Okay, so this one is for backward. This is the value for centered. Centered difference. Oh, sorry, centered. Just try so that you know how to do it and make sure you get the correct value. So for centered, just now you already calculated for F1. Then that you get for it 0.1. For it 0.25, you will get 0.25 to 0.5. And that yeah, let's say your H is 0.5, X 0.5, 1, 0. So you will take the value for X and 1. 0 and 1. Okay, minus them. This is your X. 0.5 is your X. For H equals to 0.25, different scale. So you will have X is 0.5, 0.75, and 0.25. Okay, so you will get something like this. So this is your figure in between these two. Yes. Now the question will ask you to determine whether forward, backward, or centered. And the equation will be given in the test and final exam. Okay. Okay, from the previous statement, when you have different, I go back to the previous slide. Okay, I'll hide. I move to previous slide further. Okay, here you see, you notice the difference of the error. H 0.5 is 58.9, H 0.25 is 26. So we can say half the error. So half the step size will halve the error. That is what meant by this statement in this slide. Halving the step size will halving the error. So the smaller the step size, the smaller your error. For centered, it will quarter the error. Okay, the smaller the step size, the smaller the error again. So for centered, is it quartered? 3/4. Okay. So this error value prove the statement just now. Okay. Okay, again. This equation, it gives you function of this. Okay. So the question, it can give you any function of fx. This one in the highest is x power 4. Okay. Let's try if your fx is in this form. Okay, fx, please do not be confused. The fx term is equivalent to y. Sometimes the question use y. Sometimes the question use fx. Okay, because in plotting the graph, we have x-axis and y-axis, right? Sometimes they use the term for y-axis as fx, function of x. Okay, so y is equal to fx. Now it gives you this function. Exponent sine x plus 5x power 2. X power 2. Starting with x equals to 2, step size 0.5. Step size here is the h. Using forward, backward, and centered. Okay, I guide you for the first step. Later the rest try to do. Okay, for forward, we know for forward, the equation is f prime x equals to fx plus h minus fx over h. Okay. The given value of x is 2, h is 0.5. Okay, let me know if I go too fast. Now, we want to find for forward f2 plus h minus f2 over 0.5. Okay, so now you need to find out what is f2.5 and f2. How to calculate f2.5? Using this equation. So f2.5 using the equation over here, y e sine x. Okay, so e exponent sine 2.5 plus 5, 2.5 power 2. Okay, you try first. Sorry? Okay, then find f2. Replace the 2.5 with 2. Then from there, you should get 21.1735. Let's see. Power 2. This one is x power 2. X power 2. So there will be a difference if you use degree and radian. What do you use, radian or degree? Radian. Wait, let me check. Sorry, the answer is different. What you get? I recalculate, I get different answer. Mm-hmm. 22.4. Using the mode radian, right? Same, huh? Okay, let's check, huh? Sorry? 33. Okay, so for f2.5 with mode radian, you should be getting 33.0693. F2, 22.4826. Okay, so here, divide by 0. F2.5 minus F2 divide 0.5. Huh? You get the same? 21. So it should be getting around this figure. Correct, lah, just now. It depends to the decimal point that you use. This one with the mode radian. So if you, let's say you use a degree, you should be getting 4.51816. Always use radian. Yes. Okay, let me know if you need me to repeat. Okay, now this one forward settle. Try to find out for backwards and center. Yes.
2.5 we get 31. Then 2 I get 20, and then this one we get 20. Okay.
Still in the range because due to the decimal point, significant figures that you use. Is it?
I just click so totally same that. So I get 31.
Okay.
I do it again.
Huh?
Sine 2.5 times E plus.
Oh, you do like that one by one. And E, which one that you use? E? Which one that you use? If you use this, it will be different. Different number. Let's say you use, sorry, no, that one. E sine 2.5 plus this one, 2.5 over 2. So, but your answer still in the range. No issue. Should be okay. Should be acceptable. The E over here, exponent, you use shift ln. Shift ln. So you will get E, shift ln. If you use alpha ln, you will get the E in pink value. The value will be different a bit. Instead of 33, you will get 32. Get what I mean? Shift ln. Okay, what I meant just now, this one, E sine x is equivalent to E sine x plus 5x2. If you use alpha ln, it will be E different. You will get 32 something. Okay, how I get 33? I use shift ln. If you use alpha ln, your value will get 32. Still acceptable, not sure. Okay. Unless my answer is 21, but your answer is 10. It was totally wrong. Okay. Okay, try for backward and centered. For backward, we should be getting what you get for backward? 17. 17. Yeah. Where is my? Sorry. Backward should be 17. This one using shift lon. Okay. Wait. Backward, the final answer, shift lon with radian. This one. Centered. $19.1079. Get the zero, centered. For backward. Acceptable. If backward is that, then you get 7 just now. 3.7. Check your calculation. Two big difference. Please make sure you understand. This is the first part only. Later on, the calculation method will be more complex. Don't come to me during the midterm saying that I don't understand anything. Please. Okay. There's no time to reteach you everything. Okay, so we will stop up to this exercise. This is the final of chapter 1. Next class, we will start chapter 2, locating the root. Will be more calculation. Okay. Okay, for those who want to leave, you can leave. Thank you.
Is there any exercises in chapter 1?
I just uploaded chapter 1, but chapter 1 we are starting from the numerical because I follow the textbook. Okay, welcome.